All right, let's look at parallel lines and parallel planes. We'll start out with lines. Um, Suppose you're given two equations of a line, and we want to look at the different possibilities. One possibility, of course, is the two lines might wind up being parallel. If that's the case, they have the same slope, but they have a different y-intercept. And in that case, you get no solution. So that's one possibility. Remember, a solution, when we think of it geometrically, is a point that lies on both lines. And there's no point that lies on both of those. Another term we use for this is we say that this is an inconsistent system. Inconsistent just means it has no solution. All right, another possibility is one equation could be this line, and the other equation could be the exact same line. If that happens, then they still have the same slope. They have the same y-intercept, but I'm not going to write that down. They have the same slope, but the thing is they're the same everywhere. So this, if we think about how many solutions this has, a solution is any point that lies on both lines. Well, since they're the same line, there are infinitely many solutions. Any point that's on the line is a solution. So it's got infinitely many solutions. And this is a consistent system because it has at least one solution. Consistent. Okay, the third situation is where you've got one line doing this and one doing that. In other words, they have different slopes. So if you have different slopes, what you have is a single solution. And this is also called a consistent system because it has at least one solution. Now we say it has a single solution. That solution does have an x and a y coordinate to it, but it's still just one solution because it's just one point. One point is the solution. All right. So suppose you're given a couple of equations of lines. How can you tell if they have the same slope without graphing it? So let's look at this example down here. Determine the number of solutions of these. So really what we're trying to do with these is we're trying to figure out, are these lines for each pair of them? This is like a three-part example. For each one of these, you have to figure out, are these lines parallel? Are they, do they intersect? Or are they the exact same line? And here's how you do that. I'm going to write it out in general up here. Let's say you have two lines. Well, that's a very thick marker. Two lines. Let's say the equations for them are ax1 plus by1 equals c1. And then ax2. Oh wait, I need to subscript my. Scratch that. I need to put the subscripts on the on the coefficients. A1x plus b1y equals c1, and then a2x plus b2y equals c2. So what you do is you look just at this part here. If one of those is a multiple of the other, then the lines have the same slope. And that's all there is to it as far as finding if they have the same slope. Let's go down here and on each of these examples figure this out. Now it's asking us for the number of solutions. Right now, I'm just going to figure out, is the slope the same or is the slope different? All right, on this one here, 3x plus 4y you can multiply that by 2 and get this. So these two have the same slope. Okay, what about this next one? 3x minus 5y. Can we multiply that by something and get 6x plus 10y? The answer is no. If you wanted to go from 3 to 6, that says you have to multiply by 2. But if you multiply negative 5 by 2, you get negative 10. So these things don't have the same slope. They have, I think they have opposite slopes. But anyway, they don't have the same slope. So actually, we can go ahead and answer this question immediately. If two lines don't have the same slope, then somewhere they've got to intersect. So how many solutions does this have? This has one solution. All right, what about this next one? Is this a multiple of that? All right, well, to go from 4 to 6, you'd have to multiply by 3 halves. And if you multiply 2 by 3 halves, you get 3. So yeah, these have the same slope. And maybe I should write that down here. If you take 3 halves times 4x plus 2, what you get out of that, 3 halves of 4 is 6. 3 halves of 2 is 3. I should have a y there. So those guys have the same slope. So now what we've got to figure out is, for these two guys that have the same slope, do we need up here and here? Are they parallel, or are they actually the same line? Well, let's go back up here. The thing that makes it the same line is over here. So if one of these is a multiple of the other, then in order for it to be the exact same line, let's see, how do I say this? If C1 and C2 are, if we can use the same number here, let's say this is multiplied by some number k. If this is multiplied by that same k, they're multiplied using the same number, then the lines are the same. So let's look at this. On this example here, to get from here to here, we have to multiply by, what was it? Yeah, just by 2. But to go from there to there, if we multiply 12 by 2, we get 24. I guess another way you could think of this is by saying, if you take half of this bottom, half of 6x is 3x, half of 8x is 4y, half of 3 is 1.5. So it doesn't work there, so that means that these lines are parallel. And down here, if we look at the same thing, what are we doing on this? Going from here to here, we're multiplying by 3 halves. 3 halves of 4x is 6x. 3 halves of 2y is 3y. 3 halves of 10 is 15. So these are the exact same line. So I guess I didn't quite answer the question though. Up here on the first one, if they're parallel, that means there's no solution. Down here, this one, since it's the exact same line, there are infinitely many solutions. So we can figure out the number of solutions just by looking at that stuff without actually trying to solve the equation, the system of equations. Now, there's a couple more examples. Or no, actually, there's only one more example I want to look at here. For which values of t does this system have no solution? All right, if you look at this, if we go from the top to the bottom, we're multiplying by 3. So multiply by 3. So these equations are exactly the same. When 15 times 3 equals t. So when t equals 45. So is that our answer? No. Because it says, for which values of t does this system have no solution? Well, when t is 45, it has infinitely many solutions. So it has no solution. Maybe I should back up just a little bit. The equations are exactly the same when t equals 45. The lines, I should have said the lines here, not the equations. The lines are parallel for any t except 45. All right. So we need to talk about planes, but we'll do that in the next video.